Okay, so I'm going to be taking up question 40 on the extra multiple choice practice. So I'm just going to read the question out right here. It tells us that a concentrated aqueous solution of HNO3 has a density of 1.42 grams per cubic centimeter and contains 70% by mass of HNO3. And it wants us to find the concentration of HNO3 in dm cubed, dm to the -3. So what are we going to do? So first, we just need to make sure that we notice that 1.42 grams per cubic centimeter is the same thing as grams per milliliter. And from here, I guess like the key step to solving this would be to assume what the volume would be. You don't have to do 1,000 milliliters like I've done here, but it's a nice number. You can start with whatever. You should get the same answer because we're solving for concentration. So if we jump straight into it, we know that the formula for density is D equals M over V. Density is mass over volume. The question tells us that the density is 1.42 grams per milliliter. So, and we're going to be solving for the mass of the solution. So yeah, the mass of the aqueous solution of HNO3. This is the mass that we're solving for. And so this is important. If you're going to assume your volume is in liters, make sure that for this step, you convert it to milliliters because your density is in grams per milliliter, so your volume should also be in milliliters. Multiply 1,000 by this, to solve for M, you get 1,420 grams is the mass. So the mass of our aqueous solution of HNO3 is 1,420 grams. Now what we're saying is that 70% of that mass comes from HNO3. So HNO3 by itself, that's our solute. And the out of the total solution, out of the total aqueous solution, 70% of the mass comes from that solute. So let's solve for that. We're going to find M solute. So 70% by mass means that we're going to be using the mass by mass percentage formula. So that's the one where we have the M solute over M solution times 100 because it's a percentage. So 70%, that's like 0.7. So 0.7 equals M solute over M solution. Here we calculated that the solution of the total aqueous HNO3 is 1,420 grams. So plug that into M solution and multiply both sides to solve for M solute. So 70% of 1,420 is 994 grams. So 994 grams is the weight of just the just the HNO3. So now, if this is how much the solute weighs, how many moles of it are there? So that's going to be the third step. Because if we're solving for concentration, we need to know the moles of the solute, not just the weight. So we know that molar mass is mass over moles, or MR equals M over N. If you're solving for N, that's going to be N equals M over MR. And we know that M, our mass, is 994 grams that we calculated in this step. And the molar mass using your periodic table for HNO3 should be 63.013 grams per mole, around that weight. Then we just do the division, 994 into 63.013. That should tell us that 15.77 moles of HNO3 weighs the 994 grams. So now that we know, that's great. That's how many moles of HNO3 are there. Now that we know it, let's find the concentration. So C equals N over V. N is 15.77, we just calculated. V is the volume of the total solution. And this is the one variable that we were assuming at the beginning of this question. So I assumed it to be 1,000 milliliters. So I said 15.77 moles over 1,000 milliliters, which is the same thing as 1 liter. So 15.77 moles over 1 liter. The question wants it in dm cubed, and 1 liter equals 1 dm cubed. So this is 15.77 moles over 1 dm cubed, which can be written in our final answer as 15.77 moles and then dm to the -3rd power. So if you didn't do 1,000 milliliters from the start, almost all of these numbers are gonna look different until you get to the final step here. But yeah, so that's how you solve question 40.